Okay, so before you get started on your angle proofs, I want to go over some of the definitions together. Remember, a definition has to be biconditional. You can say it both ways. So if you look at definition of congruence, we already know what congruence is, right? It's taking the measurements and making a congruency statement. You will notice in your measurement statement, you must have the M included before the angle. So the measure of angle A is equal to the measure of angle B. Therefore, angle A is congruent to angle B. So make sure you have this M written in there when you have equality. And again, it's biconditional, so you can say it both ways. That's definition of congruence. When you have definition of a right angle, an angle measurement is 90 degrees if and only if, there's that biconditional, it is a right angle. So you can say the measurement, notice we're talking about equality, so it's the measurement of angle A equals 90 degrees, then angle A is a right angle. And remember, you can also say angle A is a right angle, therefore measurement A equals 90 degrees. All right, next we have definition of complementary angles. So two angles are complementary if and only if the sum of their measures is 90 degrees. So again, it can go both ways. Supplementary, there's nothing new there. Supplementary angles are 180 degrees, and if the sum is 180, then they're supplementary. Definition of an angle bisector. So remember, an angle bisector is very, very similar to a segment bisector. So what does an angle bisector do? It divides an angle into two equal parts, just like a midpoint divides a segment into two equal parts. And then definition of perpendicular is that perpendicular lines form right angles. So those are the definitions that you're going to be using in the reason column. In the postulate column, the big postulate that we had was the angle addition postulate, very similar to the segment addition postulate. And notice what this allows me to say. The measure of angle ABD plus the measure of angle DBC is equal to the measure of angle AMC. Notice when we're in equality mode, I must have the measure included before each angle. Okay, now let's look at our theorems. The vertical angle theorem is that if two angles are vertical, then they are congruent. You can also say, no, you can't. Congruency doesn't call vertical angles. Your complement theorem, that is why it's a theorem, not a definition, by the way. Because remember, definitions have to be biconditional. Your complement theorem is that if two angles form a right angle, then they are complementary. And your supplement theorem, also called linear pair, is that if two angles form a linear pair, then they're supplementary. All right, so that's kind of, you've seen that before. Now, here's what I want you to do. I want you to highlight congruent complements theorem and congruent supplement theorem. This, to me, is tying. You are combining transitive property with congruency. And you'll see what I mean in a second. So, congruent complements theorem says that if two angles complementary to the same angle, then they're congruent. So look at this. If angle A is complementary to angle B, and angle C is complementary to angle B, then angle A is congruent to angle C. So this is really a transitive property. A and B, C and B, and now that B is the same, I can now say angle A is congruent to angle C. So to me, it looks transitive, but it's congruent complements theorem because remember, in transitive properties, it's all about equality, but it looks very, very similar to this, okay? So if they're complementary to the same angle, then we can claim this congruency statement. And it's the same thing for congruent supplements theorem. If two angles are supplementary to the same angle, then they're congruent. Looks like transitive property, but you'll notice transitive property is just doing equality statements. So because this is congruency, we call it congruent supplements theorem and congruent complements theorem. Okay, so that's just kind of a review of all the different definitions, postulates, and theorems that you're going to be using for your angle statements. Now, flip it over. I want you guys to take a few minutes to do numbers 1 through 12 on your own. Pause the video and then come back. All right, so let's see if we got the same answers. So number 1, what is this reasoning? It is definition of a right angle. I'm abbreviating, you are not. Okay. This one, if angle X is supplementary to Y and X is supplementary to Z, looks like transitive. It's not transitive. It's the congruent supplements theorem. Congruent supplement theorem. Okay. If angle 1 and 2, then angle 1 is congruent to angle 2. This is your vertical angles theorem. And notice the only reason this is a theorem, not a definition, is because it is not biconditional. Okay, it doesn't go both ways. Number 4, if angle P is the measure of angle P and the measure of angle Q is 90, then angle P and angle Q are complementary. That is, number 4 is definition of complementary angles. Okay. Number 5, if angle M and angle N form a right angle, then angle M and angle N are complementary. That's your complement theorem. Okay, and this is my given statement. L is perpendicular to M, then angle 1 is a right angle. That is definition of perpendicular. Okay, if W and X are supplementary, then the measurement of W plus the measurement of angle X is 180. That is your definition of supplementary angles. Okay. Number 8, you've already read these, so I'm just going to give you the answer. Number 8 is congruent complements theorem. Complements theorem. Number 9 is linear pair or supplementary theorem. I don't care which one you do. Supplementary theorem is what I'm going to say. Supplementary theorem. Keep it consistent. Number 10 is definition of complementary. Number 11 is your angle addition postulate. And number 12 is definition of congruence. Okay, so I hope we got the same thing, but that is your cheat sheet. Now you guys are going to be starting to do the notes with your table. Good luck.